Hi, Raymond Hunter here. This video was going to be all about how to verify various trig identity examples. It turns out it's about verifying one trig identity in ChatGPT. Let me explain how I came up with this. I know that students are in the second half of Algebra 2 Trig and Pre-Cal. In those semesters, you're covering these verifying trig identity type problems. I know students struggle with these because there's not a simple way to start them. It relies on familiarity, it relies on some intuition and some strategies. And you may work a ways and then find out you're kind of dead ending, have to go back, start over. And there's multiple different ways of verifying pretty much any of these things. So students really struggle with these. So I thought to myself, maybe I can be of help. Maybe I can provide a way of understanding these things in a way that really resonates with students. So I searched Google for lots of examples. What are they showing you? How are they working them out? DuckDuckGo, same thing. Textbooks, lots of textbooks. What are they showing you? And finally, I watched at least 100 YouTube videos on this. And the YouTube videos, this is what I found. Some are pretty good. Some show strategies that I definitely would not recommend for those particular problems. Some take forever to get to the end, and there's much cleaner ways of doing them, and some are just flat out wrong. But the one thing they all have in common is they're old. A lot of them are like 10 years old, 8 years old, 4 years old. In the meantime, ChatGPT has come onto the horizon. So I thought to myself, students have got to be using this. In fact, if I were a student and I was struggling in math, I'd try this out. In fact, I was that student. So let me give you a little background about my history with education. So in high school, I was on the honors track, but it was not a good high school. And the most advanced math class we offered was pre-calculus. And if you were on the honors track, you took that as a senior. And I'm pretty sure I got a D in there. I ended up though at a top university. I studied math, engineering, and physics. I ended up with a near perfect GPA, Latin honors, Phi Beta Kappa, and then on to grad school, math, engineering, and actuarial science. So somewhere in there, I transitioned from not understanding a whole lot at all to mastering the material. And so my point is that I get it. I was in the same boat. I would have jumped on this. In fact, some of the nonsense ideas, I probably would have turned it in and put it on for assignments and turn it in and hope I got credit for it. So what I want to do and what makes this video different is I want you to understand how chat works and that you shouldn't use it. It doesn't know math. It doesn't do logic. It just predicts. It's a large language model form of AI. Here's how it works. It ingests enormous amounts of information off the internet. And when it does this, and it's creating its models, it can take months and months with hundreds and thousands of computers to process all this information to generate its models. And then the way it works is this. So let's say, for example, I have this trig identity that I want it to do. So I feed it this identity. And what it does is it searches for a whole bunch of what should my first step be. And it searches for them. And then it says, well, which ones show up more often? And then maybe it serves you up the first step as the one that shows up most often. And then what it does, it feeds that back in. So it feeds in the original, the first step, and it says, okay, what should the next step be? And again, it goes through the cycle and it looks for all the different next steps that are likely, and it prioritizes them based on the number of occurrences. And then maybe it chooses the most popular one, or maybe it doesn't. Maybe it chooses one that's down the list only because it's trying to seem more natural. It doesn't want to give the same answer every time. So even though these outcomes are deterministic, it wants to sound more natural. So it may give you an answer that's different or less popular. So let me give you an example that's more physical that you might be able to relate to. So let's suppose you want to work through this identity, this one right here. So you write it down on a piece of paper and you run out into public. And if it were possible, you talk to millions of people and you say, what should my first step be? And then, now, yes, some will run away from you because it is math, but let's say those that do answer, you write down those answers and you rank them according to the number of occurrences, and maybe you choose the one that shows up most often. And then you write that on your paper. And then you have your original problem and you have your first step. And then you run out into public again and you ask millions of people, you go, what should my next step be? And again, you go through the cycle and you rank them. And then this time you might say to yourself, you know what? I realize this one's most popular, but the people giving these answers, they just looked smarter. So I'm gonna use that one. So you put that one on your paper and you go back out into the public and you just kind of cycle through that. That's kind of how chat works. It's not that simplistic. It's far more advanced than that. And there's many different algorithms, but I wanted to give you a real physical example so that you could kind of wrap your mind around how this really works. And so what I want to do is, my goal here is to show you, I'm not going to just go through this and we're going to laugh at the answers, although we will do that, but I wanted to go through this stuff so that you can understand how chat operates, and maybe you can find a way to use it as a valuable tool for maybe other kinds of math problems or other areas, but you understand its limitations and what you can do with it and what you can't do with it. So that's kind of my goal with this one, whereas others are saying just don't use it, it's the devil. You know, I'm just saying, look, it doesn't work, it can't do math, it doesn't know logic, but I'm not saying it can't be a valuable tool. So let's walk through this. Let me help you to understand this. So what I did first was I found some trig identities that pretty much everybody's doing. Like all the YouTube videos have it, whole textbooks, everybody's doing this. And I fed it into chat. I fed these into chat, and every single time it got them right. No problem. And even though I got them right though, I want to emphasize here, the problem with this is, yeah, sure, you might be able to turn in your homework, but how do you know? And this is the hard part. This is the hard part of these, and this is what makes these problems hard, is how do you know what your first step should be? How do you know what you should try? That's the hard part. So when you're just writing down the answers, you're not thinking it through like that, and it's certainly not explaining it. So yeah, you might be able to turn your homework, but when you sit down and take a test, you draw a blank. So unless you absolutely positively remember that particular problem, which is possible, you're not gonna probably do very well on that. And then the other thing is if you get something that's harder than that, more advanced, you don't have any experience to draw from to even have a chance of getting that one right. So you definitely don't want to rely on chat for this stuff. So here's what I did. I found a trig identity that I only found in one textbook. And I consider a medium level of difficulty. I don't think it's terribly difficult. I fed it into chat, and here's what it did. I say, chat, verify this identity. And it responds, and it's very peppy. It says, hey, let's verify this thing. And what it does is it says, step one, let's simplify the numerator on the left side. So let me make two comments here. One, it started with the side that seems most busy. And in fact, in this case, I actually did the same thing. I did this trig identity in one step, one step, literally. But I did start with the busier side. I don't always do that. And I'm thinking maybe I'll put a YouTube video out on this. Oftentimes you can start, I wouldn't say all the time, but quite a few times, you can start with a more simple side. And there's a trick that I use it all the time to successfully work through these. And I'll try to put a YouTube video up on this later. But that's what it did, is start with a busier side. The next thing is, it says, okay, you got a sine squared minus 1. And the advice that I would give students is, if you have a squared trig identity, maybe you should, and a 1, maybe you should start thinking about those Pythagorean identities. There's 3 of them, and there they are right there. So when you have a sine squared or cosine squared or tan squared, cotan, secant, cosecant squared, and a 1 or a minus 1 plus 1, it doesn't matter, maybe you should be thinking about using those identities. In this case, I would not recommend this, and here's why. Now, it seemed to think that you should, and it says to simplify it. So it figures, well, I'm going to replace the sine squared minus 1 with negative cosine squared. So I've got 1 term instead of 2, and that's more simple. So that's where we're going to go with this. My feeling is this. Let's pause for a moment. Let's just take a look at this original identity. So in the most fundamental idea behind verifying this is you want one side to look like the other side. That's it. That's what you're trying to do. I want this side to look like this. I want the left side to look like the right side. So let's look at the left side. What do we got? We got sines, 1, tangents. Let's look at the right side. What do we got? Sine 1 tangent. So why would I throw in a cosine squared? It seems to me it's going in the wrong direction. So although that could be a strategy, it is all over the internet. Try these Pythagorean identities. I would not do it on this. All right, but it did. And then it goes to the next step. It says, all right, on the left side, we've got a tangent. Let's replace that with sine over cosine. And again, that strategy is all over the internet. Personally, my experience is there are some problems that is definitely the way to go. But in many other problems, it is definitely not the way to go. And in some, it's like a Hail Mary. You just go, I don't even know what to do. I'm gonna put sines and cosines in. I'm gonna massage them, do a lot of algebra, and just hope that something will shake out of this. To me, it shows a lack of control over the problem. And you're just kind of hoping that you'll end up with the right outcome. And a lot of times, with many steps, and you go around in a circle, and the thing just gets busier and busier, and you end up getting nowhere. But anyways, that's what it did, and that's probably why it did it. So then it ends up, after it does the algebra and simplifying, it ends up with a cosine cubed in the numerator. If you get a cosine cubed in this thing, you're definitely going the wrong way. You would definitely want to backtrack and go all the way back to the beginning and start something different. And it seems that chat kind of figured that out. It figured out, okay, something's not going right here. This is getting worse. It's not looking good. So tell you what, let's start on the right side now. So let me make a comment on this. Yes, it is legit to work on the left side and the right side. You can do both. I think, again, it shows a lack of control, a lack of eloquence or doing the problem, but it is permissible. So chat does this. And once again, it says, hey, I've got a tangent here. I'm gonna replace with sine over cosine, which we've talked about, it's all over the internet. And then it gets to this mess on the right side. So it's got a mess on the left side, a mess on the right side, and they don't look anything alike. So then it seems like it's a little frustrated here. And it says, I'm gonna plug in a value. I'm gonna plug in pi over 6 and see if these two sides are the same. So I wanna point out a couple things here. First, you can always disprove something with a single counterexample. So if you plug the pi over 6 in, you don't get the right result or the same result on both sides, you've disproved this. You can never prove it though using examples. Now, we prove things, we use, okay, so proving by examples or using a lot of examples to convince yourself something's true is not proving that it's true. It's a form of what we call inductive logic. These identities, these verifying, these are deductives where you use theorems and definitions and logic. But using examples, reasoning by examples, we use this in everyday life all the time, far more than deductive logic. And it's very effective in real life. You use a little intuition, a lot of examples, and you can figure things out. So, but in math, we don't get to do that. So it plugs it in. I don't know why, because originally I said, verify this identity, which means it's true. The only reason you would plug in a value is to see that it wasn't true. Well, I already told it was true, so, but I went and did it, and somehow it says the result from the left side is not the same as the result on the right side. I don't know how I got that, but I worked it through right here, and I'm gonna pull up my work. So this is what I did. I worked it through. I inserted on the left side pi over 6 into cosine. Cosine of pi over 6 is root 3 over 2. I insert pi over 6 into sine, that's 1/2. So I insert those and I do the work and I do some simplifying and I walk through the steps and I get down to the end and I get 3 root 3 over 2. And then I put it in on the right side. So I put in my pi over 6 into every place where there was a theta and I put my values in and I simplify, I get the exact same thing, 3 root 3 over 2. So I get the same value. So how does chat not get the correct value? I can only speculate. Maybe these are pretty busy equations. Both sides are pretty busy expressions. So maybe it couldn't find something that enabled it to predict the answer. But believe me, it doesn't evaluate these things. It doesn't do the math. It just searches and speculates on what the next step and the next answer is going to be. So it got the wrong answer, and that's the way it went. And then it drew this conclusion So then what does it do? It says, well, it says it's false. And I say to it, but I know the identity is valid. And as I mentioned, I did say originally, verify the identity. So I'm telling it it's valid. And then it comes back and it says, if you know it's valid, well, let's go back and work more carefully. I'm thinking to myself, well, why didn't you work carefully to begin with? I need this answer, right? So what does it do? It goes through and it does pretty much the same thing. It replaces sine squared minus 1 with negative cosine squared, and it replaces tangents with sine over cosine, and it does it to both sides just like it did before. And then it comes to the end here and it says, okay, so I think it realizes it kind of got the same results and it doesn't know what to do. So, and I'm not gonna say chat gets frustrated or something like that, but it decides to do the unthinkable. It decides it's gonna start working on both sides, like doing operations to both sides. It decides it's gonna multiply both sides by tan theta. Can't do that. Now, I'm sure that your math teacher told you you're not allowed to work on both sides of the equation. Like you can't do operations to both sides of the equation at the same time. Most teachers don't bother telling you why. If I were you, I'd ask why. I'd be like, why can't I? Why? What's the problem with that? But the reason is this. We oftentimes take this for granted, but when you learned way in elementary school, if you have, say, x equals 2, and you want to add a 2 to both sides, you can do that. But the axiom that permits you to do these things with adding, subtracting, multiplying, dividing, there's some conditions that have to be met. First, the equation must be legit. So x equals 2, it has to be legit. And then the thing that you're doing to both sides, both things, they have to be equal. So if you want to multiply one side by 2 over 1 and the other side by 2, they're equal, so you can do that. So even though they don't look the same, they are equal. So you're allowed to do that. So if the original equation's equal and the thing you're trying to do to both sides, those are equal, then you're permitted to do that. And division has some other clarifications, like you can't divide by 0 and multiplying, same thing. So, but the bottom line is you only get to do operations to both sides if you know that the original equation is equal and that the things you're doing to both sides are equal. Tan is equal to tan, there's no problem there. But the problem is we're trying to verify this equal thing in the first place. So we don't get to use the axiom. We don't get to operate to both sides. And that's why you can't do that. But chat goes ahead and does that. And it gets to the end and it says, hey, they're the same. So I'm not even gonna go through that because it's completely invalid. But what I will do is I'm gonna pull up what I did now. So here's what I did. Again, I urge you, don't just go jumping into these things. Try to keep it as simple as possible. At the most simple level, you want both sides to look the same. So I look at both sides, I got sines, ones, and tangents. And I look at the left side, and I say to myself, I go, look, in the denominator, I have a tangent. If I were to factor that tangent out, I'd have a tangent times sine minus 1. And I'm thinking, well, on the right side, I have a tangent down there in the denominator. So, I feel pretty good about that. I've got a tangent all by itself, and it seems to me I'm going in the right direction. Now, I got a sine theta minus 1 down there as well. Somehow I got to get rid of that. So I look at the numerator, and I say to myself, I've seen this a whole bunch of times. That's the difference of squares. 1 is 1 squared. And so you got sine squared theta minus 1, which can be factored into sine theta minus 1 times sine theta plus 1. Now, before you even write it, I'm pretty excited because I got a sine theta minus 1 in the denominator. I know those are going to cancel. So now I write it down, and there it is, my second step. All I'm going to do now is cancel the sine theta minus 1 in the numerator and denominator. And really, it's one step. So the first step, factor numerator, factor denominator, cancel. The second line down, all I did was write the results, the cleaned up results, and I validated it by saying that, yes, it's equal to the other side. So really, it took one step. It wasn't that hard to do. And I did it by not applying the strategies you see everywhere. I did not use Pythagorean identities. I did not switch over to sine and cosine. There you have it. This, for me, has been one of my most favorite math videos to do, because I feel that this can really help you as a student, not only to not take a big hit, for basically cheating on your math assignment or project or whatever it is you're doing, and to help you understand that you're not going to be learning math from this, but also that maybe from what you understand about how to use chat, maybe you can use it as a valuable tool to do other math stuff. I do know that other people out there are really sharp. They actually use this, but they don't trust everything that it puts out. You really have to look at it. And the tragedy here is, like, if you were following along and your math might be kind of weak, so which is the reason that you're going to ChatGPT in the first place, and then you may not even realize that what it's feeding you is incorrect, and then you write it down, you turn it in. So that's tragic. So anyways, I've really enjoyed producing this video. I hope you got a lot out of it, and I will see you next time. Hey, thanks for watching this video. If you found it was useful, consider liking it and subscribing to this channel so you can stay updated on new content. You can also drop a comment below, because I'd love to hear your thoughts and any suggestions you might have for future videos.